This is the Geometry Unit 8 review, working on right triangles. We're going to find the length of the right triangle, the missing side. So we don't know any angles, so we cannot use trigonometry here, but we do know two sides. So we can use Pythagorean Theorem. The leg squared plus leg squared equals hypotenuse squared. You know across from the 90 is the hypotenuse. Therefore, the other two sides are called the legs. They're perpendicular to each other. So the hypotenuse squared is 24. The leg that we don't know we'll call A, and the leg that we do know we'll call 22. All right, so we have 24 squared, which is 576. We have A squared, and 22 squared is 484. So we square the two lengths that we know. We can subtract over our 484. So we have A squared. We're going to subtract the 484 from the 576. We get 92. But that is A squared. That's A times A equals 92. So now we have to simplify that if we can. So we know that 92 can be broken down into 2 times 46, which can be broken down into 2 times 23. So we have a pair. So it's 2 root 23. So A is going to equal, got the equal in the wrong spot, A is going to equal 2 root 23. Now we have the same idea. We have two sides of a right triangle. We're missing the third side. This time we're missing the hypotenuse. So the hypotenuse squared equals leg squared plus leg squared. We have the hypotenuse squared, which we don't know. 6 squared plus 9 squared. We get 36 and 81. 110, 117. So the hypotenuse is going to be the square root of 117. And that does not reduce. Now we're going to find the height and the area of an isosceles triangle. There we have our isosceles triangle with the side lengths of 4, or 14, 25, and 25. The 25s are obviously the same, so they're going to be the two sides the same, and 14 will be your base. So what we want to do here is drop what's called the altitude down, and the altitude is going to divide this into 2 equal parts. It's 90 degrees with the opposite side, and in an isosceles triangle, it will bisect the opposite side. So we actually have a right triangle with 7, 25, and our unknown. So I believe this ends up being a Pythagorean triple. But if you don't know it, we'll have to calculate it. So we have 25 squared, we have 7 squared, and our unknown, which is actually the height. 625 equals 49 plus x squared. We get 576 when you subtract the 49 over, and when you take the square root of 576, we get 24. So that's what makes it a Pythagorean triple. They are 3 numbers that are integers. So some real common ones are 3, 4, 5, 5, 12, 13, and here's the other common one, 7, 24, 25. It's not as common. Okay, so we're going to talk about the height of the triangle. The height of the triangle is 24, and these would be inches. So the area is going to equal half the base times the height. That's how you calculate area of a triangle. So the area is going to be half the base. The total base is 14. The height of the triangle, we said, was 24. You could take half of either one of those, or you could just plug the whole thing into your calculator. 0.5 times our 14 times the 24 gives us 168. (168) inches squared, or square inches. That is the area of the triangle. We have a 25-foot ladder. So here's your ladder up against the side of the house at a point 24 feet above the ground. So there's our 24 feet. The foot of the ladder is X away from the edge. We want to figure out how far out that has to be for us to be able to reach up 24 feet and have a ladder at 25. So, (24.1), 25.5. We know this is our hypotenuse. These are the two legs. We don't know any angles, so we're going to do Pythagorean Theorem. 25.5 squared is going to equal the leg squared plus the leg squared. So this gets us to 650.25. And 24.1 squared gets us to 580.81. We'll take our 650 and subtract the 580. That gives us 69.44. And we can take the square root of our answer. That gives us 8.3. Let's see, we should actually say the square root of 69.44 is 8.3. They say to round to 1 decimal point. That's 1 decimal point is approximately the x value. That's how far away from the house we'd be if those were the other dimensions. We're going to avoid a large, shallow reef, and a ship set a course from point A and travels 25 miles east. So north, south, west, and east. Right? It spells we. That's one way we remember. Or never eat shredded wheat. All right. So we're going 25 miles east to point B. The ship will then turn and travel 30 miles south to point C. If the ship could have traveled in a straight line from point A to point C, how many less miles would the ship travel? Right now, it's traveled 30 plus 25. Right now, it's traveled 55 miles. How much less is the hypotenuse? So the hypotenuse squared equals the leg squared plus leg squared. So we add them together and we take the square root. Okay, that's not a perfect square, I don't believe. But the square root of our answer, not that answer, 25 squared plus 30 squared. Okay, we take the square root of that answer. We get 39.05. We could have simplified that down a little bit, but still wouldn't have gotten it completely. And we want to do 55 minus those miles. So it's 15.9 miles longer. How many miles would the chip have traveled if the ship could have traveled in a straight line? How many less miles would the ship have traveled? So it would have traveled 15 less miles. 15.49. 55 minus 39.05 gives us 15.4. 0.94 miles. Round to the nearest tenth of a mile, that would be 15.9. That would be tenths. Okay, classify the triangle that is formed by the side lengths as right, acute, or obtuse. All right, so what we know about this, a right triangle is going to follow hypotenuse squared equals leg squared plus leg squared. So if you have the longest leg squared, and that equals the sum of the other two legs squared, the longest side squared and the other two legs squared, then you know it's a right triangle. It will be acute if the longest side, we can't call it a hypotenuse now because it's not across from the 90, but the longest side squared, if it is less than the two legs squared, the other two sides squared, then it is acute. And if the longest side squared is greater than the other two sides squared. Okay? Just to give you some comfort, this exact question is not on the test. We didn't go over this in great detail. So here we would have the longest side squared and the other two sides squared. So 26 squared is 676. 11 squared is 121. And 24 squared, we saw earlier, was 576. So we see that this is 676 compared to 697. 676 is less than. So if you're less than, you're acute. So that's how those work. Again, those are not part of our test. They are part of this review because we typically would have learned it if we would have had you in class more often. Find the value of x and y. This is a 30-degree angle. So the short leg is going to times 2. The hypotenuse equals the short leg times 2. So y equals 5 times 2. Y equals 10. The long leg equals the short leg times root 3. Well, the long leg is going to equal the short leg times root 3. So if it's a 30, 60, 90 triangle, you do not need a calculator. All right, this is the tougher one. The long leg is across from the 60. The short leg is across from the 30. And of course, the hypotenuse is always across from the 90. So if we have the long leg, we must find the short leg first. And the rule is short leg times root 3. So if we have 12, the short leg is x. We have to divide by the root 3 to get it out of there. Then we have to rationalize the denominator and simplify that. That is the value of x. That is 4 root 3. And then the hypotenuse is going to equal 4 root 3 times 2. And you only times 4 times 2. You don't do the radical. So the hypotenuse is going to be 8 root 3. In a 45, 45, 90 triangle, the legs are the same length. And the hypotenuse is going to be whatever the leg is times root 2. So in our case, the hypotenuse is going to be 4 root 2. All right. If this is 28, this is the hypotenuse of a 30, 60, 90 triangle. So this is 14. And this is 14. Because this is a 45, 45, 90 triangle, that makes it isosceles. These are both 14. This is going to be 14 root 2. So x equals 14 root 2. This side, you take the short leg times root 3. So 14 root 3. So y is the total distance. That's 14 root 2 plus 14 root 3. Unfortunately, we cannot add those two numbers together. We could only add them if the radicals were the same. Then it would be like 28 root 2. But they're different, so it's unlike terms. So the only way we can get a total is if we go to our calculator, 44.0 or 44.05. All right, it says keep our answers in simplified radical form. This would be your answer. You cannot add those together. But in terms of a decimal, that's 44.05. Use the right triangle. The sine of A, that would be the opposite over the hypotenuse. That would be 7 over 25. The cosine would be 24 over 25. The tangent would be 7 over 24. Ooh, what is the angle? This is a Pythagorean triple. Unfortunately, and it's pretty obvious, this is not 30, 60, 90. The hypotenuse is not 2 times the short leg. So don't fall into those traps. You could use any one of those. If you would like to use the sine, we will say sine of angle A equals 7 over 25. So the measurement of angle A equals sine inverse of 7 over 25. Sine inverse of 7 divided by 25. That is 16.26 degrees. Sine of B, the opposite over the hypotenuse, is 24 over 25. Cosine is 7 over 25. And the tangent is 24 over 7. You can use any of those trig functions, or you could subtract from 90. Let's just do the trig thing again. So we'll use cosine of B equals 7 over 25. So now the measurement of angle B equals cosine inverse of 7 over 25. Cosine inverse, you have to use the -1 if you're plugging in side values. That gives us 73.74. The measurement of angle B equals 73.74. That and this answer plus this answer, that should give you exactly 90, because acute angles in a right triangle are complementary. They add up to 90. Find the height of the building when A is 35. We're 150 away from it. We're at an angle of 35. What is the height of the building? So this is the adjacent, this is the opposite, so that's going to be, if we use SOHCAHTOA, we're going to use opposite and adjacent, so the tangent of 35 equals the opposite side, which is h, over the adjacent side, which is 150. We're going to cross multiply and say 150 times 35 equals h. (150) times the tangent of 35, that's 105.03. See if that makes sense. This is 35 degrees. The other angle is going to be 55 degrees. Across from the 55 is a bigger number, so it has to be bigger than across from the 35. 35's not open as much, so it's not going to make quite as big of a side. So 105 is less than 150, so that makes sense. It's a reasonable answer. And these are feet. You always want your units. All right, Lola drives 19 kilometers up a hill at a grade of 15 degrees. What is the horizontal distance? So this is your adjacent side. This is your hypotenuse. SOHCAHTOA tells us that adjacent and hypotenuse is cosine. So we have 19 times the cosine of 15. That gives us 18. Round to the nearest hundredth, 18.05. And these are kilometers. So at 15 degrees, that's not very steep. I have it drawn much steeper than it probably reality is. So 18. It still has to be less than the hypotenuse, so that makes sense. Solve the right triangle. So we know we have measure A, measure B, and measure of C. We have side AB, side BC, that's AB. BC, and AC. Those are the things that we need to solve for in terms of knowing what the solving a right triangle is about. If A is 20, if A is 20, C is 90, then the missing angle has to be 70 degrees. If A, side A, that's the one across from angle A, always. Side A is supposed to be 6.2. That's BC. All right, I typically circle it if that's the one we solved for. We didn't solve for it. That was given to us, so we'll just say 6.2. Now we need to find the other sides. This is not 30, 60, 90. We cannot just double it to get the hypotenuse. We're going to have to say opposite over hypotenuse. So the sine of 20 degrees equals the opposite over the hypotenuse. I'm not going to put down x. I'm going to use AB because I don't want to forget what I'm solving for. So AB times the sine of 20 equals 6.2. So AB is going to be 6.2 divided by the sine of 20. No, that's just sine of 20. I didn't get the 6.2 in there, huh? 6.2 divided by the sine of 20. There it is, 18.13. And we solved for that one, so we circled that one. All right, now for AC. Well, you could do Pythagorean Theorem. You can do another trig value. If you want to go from 70 this time, opposite over adjacent. So this would be tangent of 70 equals the opposite side over the adjacent side. So this is 6.2 times the tangent of 70 equals AC. 6.2 times the tangent of 70, 1703. All right, so we solved the right triangle. We found all the missing sides and angles. In this case, we are looking for the measurement of angle A, measurement of angle B, measurement of angle C, AB, BC, and AC. Those are all the values we're looking for. Side B is considered AC, so that is 18. Side C is across from angle C, so we could call that AB. That was 25. So what we don't know is side BC. So we can calculate BC by doing Pythagorean Theorem. 25 squared equals BC squared plus 18 squared. 625 equals BC squared, and 18 squared is our 324. So 625 minus 324 gives us 301. and we have to take the square root of both sides. And that gives us answers that would be 17.35. All right, now for our angles. We know that angle C is 90. So for us to find out angle A, we're going to have to use some trigonometry, some opposite over the hypotenuse. We know that, let's use the size that they gave us. So let's say that this is 18 and this is 25. So from B, we would say sine of B equals 18 over 25, the opposite over the adjacent. The measurement of B is going to be sine inverse of 18 over 25. Sine inverse of 18 over 25. That is 46.05. That's the measurement of angle B. And 90 minus 46.05. 90 minus our previous answer is 43.95. Okay, and those are two values we solved for, and we solved for this side. Okay, we're going to calculate AB. So what we're looking at is 1 step, 2 steps, 3 steps, 4 steps. That's 4 across. That's 2 up and down. So AB squared equals 2 squared plus 4 squared. AB squared, we don't know what that is 4 plus 16. AB squared is 20. So AB is the square root of 20, which is known as 4 times 5. We know the square root of 4. So that gives us 2 root 5. That is the length of AB. The angle of elevation is this guy. So we need to say that tangent of angle A equals the opposite and adjacent. Those are the two measurements we know for sure. Opposite over adjacent. So the measurement of A equals tangent inverse of 1/2, or 2 over 4 would be fine. Tangent inverse of 2 divided by 4 is 26.57. That is the measurement of angle A. That's the angle of elevation. That's the looking up. Mr. Florkowski is standing on a cliff and sees 2 goats. So he's standing there. He sees 2 goats. On the ground below him. The ground 48 feet below him. Let me be sure that looks like 48. The angle of depression between the 2 goats, depression, remember, is 48. And the other angle is 34. So we have a triangle. If that's 48, how do you want to make your triangle? You want to make your triangle here. The 48 is not in the triangle. You could call it alternate interior if you want to call this your 48. Or you can do 90 minus the 48, 42, and figure out that angle. But the common mistake is people calling this 48. That's not 48. That one's 48. So I'll say 90 minus 48 is 42. So this is 42 because we have a right angle. Just like we have a right angle. Now we have a triangle. Side of 48 and an angle of 42. We want to find out these distances in here. So this is going to be opposites over adjacent. So we multiply. (48) times the tangent of 48, 53.31. That's the distance from the edge of the mountain or the cliff to the first goat. Now we're going to come down here. We could say 90 minus 34, and that's going to give us 56 degrees. So we have this new triangle. We have a goat here, and we have a goat here. This new triangle has 34 degrees. 90 minus 34 is 56. This is still 48. So we're going to say opposite over adjacent from our 56 degree. Y is all the way across. Opposite over adjacent, multiply. So we have 48 times the tangent of 56. So y is going to be 71.16. So the whole thing is 71.16. Part of the whole thing is 53. So we're going to take the 71 and subtract the 53 to find out the 17.85 is the leftover amount. If the whole thing is 71.16 and part of that whole thing was the 53, the leftover is 17.85. Those add together to make 71. So, to show that work, we did 71.16 and we subtracted 53.31. And we got 17.85. All right, and this page, this is about law of cosines and law of sines. Hope you didn't stay up late trying to figure out that. that again is a topic we would normally cover, but because we only see you once or 2 or 3 times a week, actually 0 this past week, that's the most that we can cover. So we won't be covering law of sines or cosines, but we do have a lot of the trigonometry in here and right triangles and Pythagorean theorem. Okay. Good luck.